What's up everyone? It's Stack Lessons here. Welcome back to the channel. Today we're diving into Agent Bricks, Knowledge Assistant, Multi-Agent Supervisor, and Information Extraction. Let's get into it. Your team just got handed 3 projects in the same sprint. 40,000 vendor PDFs that need to become a clean table, a cross-domain chatbot that has to route questions across HR, finance, and engineering, and a citation-grounded Q&A bot over your internal docs. 3 problems, 3 agent bricks, and one of them is the wrong tool more often than you'd think. By the end of this video, you'll know exactly which brick to reach for, and just as importantly, when to walk away from bricks entirely. In episode 4, we drew the line between standalone calls, retrieval augmented generation, and full agents. DataDino, for example, chose RAG over fine-tuning so curators can update extinction dates without retraining the model, and we landed on a key idea. One tool calling agent usually beats a tangle of 5. Today is the exception to that rule. When the problem spans structured tables, unstructured documents, and external tools all at once, you reach for agent bricks. Let's see why. Before we dig in, let's pin down 5 terms you'll hear throughout. Knowledge Assistant is the brick that builds a citation-grounded chatbot over your documents. Instructed Retriever is the retrieval engine inside it, a purpose-built reasoning model that rewrites queries using system-level instructions. Multi-Agent Supervisor routes one user request across many specialist subagents. Information Extraction turns unstructured documents into structured JSON, and AI Extract is the underlying SQL function it's built on. Every team building on Databricks eventually hits the same 3 problems. The first is a chatbot that can answer questions about internal documents, with citations back to the source. The second is one assistant that can span structured tables, unstructured docs, and external tool calls in a single conversation. And the third is a pipeline that takes thousands of messy PDFs and produces a clean, structured table you can query. Each of these used to mean weeks of custom work, picking models, writing prompts, building evaluation harnesses. Agent Bricks exists to close that gap. Here's the core idea behind Agent Bricks, and it's a real shift in how you build. You don't pick a model, you don't write evaluation harnesses, you declare the task, answer questions about these documents, or extract these fields from these PDFs, and you point at the data. The platform then auto-generates a synthetic evaluation suite, tunes prompts and model choices against it, and surfaces the quality versus cost trade-off. That's why we call it task first, not code first. Think of it like Lego sets versus raw bricks. On the left, Agent Bricks is the Lego set, a pre-built template per task type, an auto-generated evil suite, auto-tuned prompts and models. You ship in days, but customization is narrow. On the right, the Mosaic AI agent framework with a custom PyFunc gives you a bin of raw bricks, hand-authored agent loops, custom judges, total control over tools and state. You ship in weeks, but you can build anything. Knowing which mode the scenario is calling for is the core decision skill here. 3 bricks, 1 for each of those problems. On the left, Knowledge Assistant is the chatbot over documents brick, with citations and the Instructed Retriever architecture, backed by an AI search index. That's the new name for what used to be called vector search. In the middle, Multi-Agent Supervisor routes across specialist subagents and tools, up to 30 of them combined, and enforces Unity catalog permissions. On the right, Information Extraction turns unstructured documents into structured JSON, schema-guided, with a 128,000 token context window. The rest of this video is about matching the scenario to the right box. Let's start with the most common need, a chatbot over your own documents. Knowledge Assistant builds exactly that. Citation-grounded, in days. You give it up to 10 knowledge sources per assistant, and a source can be one of 3 things. It can be a Unity catalog volume holding PDF, docs, PPTX, Markdown, or text files. It can be a Unity catalog table with a file column, or it can be a Databricks AI search index, which is the current Amazon Web Services name for what used to be called Mosaic AI Vector Search. Whichever source the answer came from, the chatbot links back to the specific passage. That's the citation grounding piece. Here's how Databricks describes it in the official docs. Notice that last clause, Knowledge Assistant follows an instructed retriever approach to address the limitations of traditional retrieval augmented generation. That phrasing is deliberate. Databricks is flagging that this isn't just a friendlier RAG UI, it's a different retrieval architecture, engineered to outperform plain RAG. Let's see what that actually means in practice. Picture two librarians. The first one, traditional RAG, judges books only by how similar the cover colors look to your request. Cosine similarity is the only signal. Metadata, if it gets used at all, is a post hoc filter. There's no notion of source authority, no notion of recency. The second librarian, the instructed retriever, actually weighs recency, source authority, and metadata as first-class signals. She reads your sticky note that says, "Only books from the last 2 years, peer-reviewed, no opinion pieces," and she writes a real catalog query from your intent plus those constraints. That's the architectural difference. System-level instructions shape the query itself, not just filter the results. Here's what's actually happening under the hood. The user query comes in on the left, something like, "What's the latest extinction data?" Alongside it, system-level instructions arrive, recency rules, source authority, metadata filters. Both flow into a specialized 4 billion parameter reasoning model. This model is purpose-built for search. It takes the intent and the rules together and writes a real, source-aware query. That query then drives retrieval. The output on the right is grounded retrieval, not just the nearest vectors, but the ones that actually satisfy the constraints. This is the contrast worth burning in. Knowledge Assistant is not RAG with a UI bolted on top. The instructed retriever is a different architecture, engineered specifically to outperform vanilla RAG, not wrap it. Next, let's look at the numbers that back that claim up. And the numbers Databricks publishes are striking. Start with the baseline, a vanilla cosine similarity RAG pipeline, which is what most teams build first. Against that baseline, retrieval recall lifts by roughly 35 to 50% on the star-RK instruct benchmark, and Knowledge Assistant as a tool outperforms it by over 30% on Databricks Enterprise QA benchmark suite. The takeaway is not the exact figures, it's that the gap is large enough that the architectural distinction matters in practice, not just on paper. Now the specifics, because scenario questions love specifics. 10 knowledge sources is the hard cap per assistant. Unity catalog volume sources accept PDF, docs, PPTX, Markdown, and text. If you use an AI search index as a source, it must use Databricks GTE large N. No other embedding model is accepted. Files over 500 pages or 50 megabytes are silently skipped at ingestion, which is how teams end up with a chatbot that mysteriously can't find half its content. And Knowledge Assistant is English only. Now the second brick, Multi-Agent Supervisor coordinates up to 30 agents and tools, combined, to answer one user request. There are 4 supported subagent types: Genie Spaces for structured tables, agent endpoints which can themselves be other knowledge assistants, Unity catalog functions for type tools, and MCP servers for external integrations. Notice that bricks compose. A supervisor can route to a knowledge assistant as one of its subagents. One important nuance, though: the supervisor routes. It does not currently do multi-hop reasoning across subagents in a single turn. The official docs are worth pinning down here. The canonical 4 are Genie Spaces, agent endpoints, Unity catalog functions, and MCP servers. These are the only subagent types the supervisor natively supports. If you see something else, like a stored procedure or a raw model serving endpoint, that's not part of the official set. Think of the supervisor as a hospital triage nurse. A patient walks in with chest pain and a billing question. The nurse doesn't try to do both. She routes the cardiac issue to cardiology and the billing question to the billing desk. The supervisor works the same way. The user question comes in at the top. The supervisor large language model sits in the middle. Underneath, the 4 subagent types fan out: a Genie space for structured tables, an agent endpoint like another knowledge assistant, a Unity catalog function for typed tools, and an MCP server for external systems. 30 agents and tools combined is the hard cap. Now here's the piece that makes Supervisor different from a homegrown router. Permissions are routing. The supervisor honors Unity catalog permissions per end user in real time. If the calling user doesn't have access to a subagent, that subagent isn't even on the routing menu. It's invisible to the supervisor model for that conversation. You don't re-implement row-level security in your agent code. The governance is baked into the routing layer. Each subagent type checks a different Unity catalog grant. Agent endpoints need can query on the serving endpoint. Unity catalog functions need execute on the function. MCP servers need use connection on the MCP connection. Genie Spaces need can run on the Genie space, plus grants on the underlying tables. And here's the failure mode worth flagging early. If a user has 0 accessible subagents, the conversation simply ends. It doesn't error loudly, it just has nowhere to route, which makes it easy to miss in testing. Pause for a second on what we've seen so far. Knowledge Assistant and Supervisor are both conversational. A user asks a question, an agent responds in real time. The third brick is different in kind. Information extraction isn't a chatbot at all. It's a batch pipeline. Documents go in, structured rows come out. That shift in shape changes how you deploy it, how you size it, and which scenario cues should point you to it. Let's look at it. Onto the third brick. Information extraction turns unstructured input into structured JSON. Natively, it handles text columns in a table and document files, things like Markdown and plain text. PDFs are not yet supported directly, so they need a pre-processing step. You run the AI parse document function to convert each PDF into Markdown first, and then point information extraction at the resulting Markdown table. From there, you define a schema in natural language, listing field names, types, and short descriptions. Under the hood, it's built on the AI extract SQL function with a 128,000 token context window, and it deploys in 2 flavors: as a straight SQL query for one-shot work, or as a Lakeflow Spark declarative pipeline for incremental, streaming extraction. The docs make the relationship explicit. Information extraction is the visual UI built on top of the AI extract SQL function. The brick gives you a UI to define and optimize the schema. The SQL primitive is what actually executes. That's why deployment can be either SQL or a Lakeflow pipeline. Both forms call the same underlying function. Here's the mental model that makes everything click. Picture handing a stack of receipts to an intern, along with a fill-in-the-blank form, vendor, date, total, line items. The intern reads each receipt and fills the form, and you get back a spreadsheet. You never wrote a parser. You never wrote a regular expression. You just defined the form. In information extraction, the form is the schema. That schema-first thinking is the whole point. The flow is 4 steps. First, define the schema in the visual UI, fields, types, short descriptions for each. Second, the platform auto-tunes. It generates evaluations and optimizes the prompts and AI extract configuration against them. Third, you deploy as SQL for a one-shot run over an existing table or volume. Or fourth, wrap it as a Lakeflow Spark declarative pipeline, which uses autoloader under the hood to extract from new files incrementally as they arrive. That last option is the one you reach for when new documents land continuously. Let's make it concrete with DataDino. They had 40,000 quarterly excavation PDFs sitting in a Unity catalog volume. Every dig site formatted reports differently, with no consistent template. Because information extraction doesn't read PDFs directly, the first step was a pre-processing parse. AI parse document converted every PDF into a markdown table. From there, they defined a schema once: genus, species, era, dig site, depth, condition, and pointed information extraction at that markdown. Out came a clean delta table the museum catalog could query directly. They deployed the whole thing as a Lakeflow pipeline, so new quarterly reports get parsed and extracted automatically the moment they land. No custom regex, no fine-tuning, just a parsing step, a schema, and a target. Let's go one level deeper on DataDino's chatbot, because the mechanics matter. They wired Knowledge Assistant to 3 Unity catalog volumes: curator notes, exhibit PDFs, and species guides. The freshness loop is the part worth understanding. When a curator opens the source PDF and edits an extinction date, that change flows into the Delta Sync index, and the next visitor question reflects the new answer, with a citation pointing right back to the updated document. No retraining, no manual reindex. That feedback loop is what made this project ship in days instead of the weeks a hand-rolled rag chain would have required. Here's the decision tree that ties everything together. Start at the top. What does the scenario actually say? If it talks about a chatbot, documents, and citations, follow the left branch to Knowledge Assistant. If it describes a request that spans structured data and unstructured data, or needs to coordinate across multiple specialized domains, the middle branch lands on Multi-Agent Supervisor. And if it says extract specific fields from PDFs or documents into a table, the right branch goes to Information Extraction. The Q is almost always the verb in the requirement: answer, coordinate, or extract. If you remember nothing else from this video, remember this one rule: answer with citations maps to Knowledge Assistant, coordinate across domains maps to Supervisor, extract into a schema maps to Information Extraction. 3 verbs, 3 bricks. Once you've internalized that mapping, most scenarios resolve in a single read. Now the other side of the decision. When is Agent Bricks the wrong tool? On the left, stay in Bricks for the standard cases: a chatbot over docs with citations, routing across the 4 supported subagent types, schema-guided extraction from documents, English content with a standard quality bar. On the right, fall back to the Mosaic AI agent framework with a custom PyFunc when you need exotic toolchains, the templates don't expose, custom large language model as judge logic the auto-eval can't express, multi-hop agentic workflows with LangGraph style state, or non-English content. The keywords in scenarios are custom judge, multi-hop, LangGraph, PyFunc, or non-English. Here's the escape hatch in action. Imagine a scenario where a legal team needs an agent that reads a contract, looks up 3 referenced clauses in a separate corpus, reconciles them with case law, and produces a custom compliance score using their own scoring rubric. Multi-hop reasoning, custom judge, domain-specific scoring, that's 3 signals that no brick fits. The right answer is to build it as a PyFunc agent on the Mosaic AI agent framework. Recognizing those signals is the same skill as recognizing when a brick does fit. Before we wrap, a few production constraints worth committing to memory. Knowledge Assistant AI search sources must be Delta Sync indexes. Direct access and self-managed indexes are rejected at ingestion. The Databricks GTE large N endpoint that powers it must have AI guardrails and rate limits disabled. Supervisor routes a single turn to one subagent. It does not chain across subagents in one call, so if your workflow needs multi-hop reasoning across agents, reach for a framework outside bricks, and information extraction caps at 128,000 tokens per document, so longer inputs need chunking first. Keep these 4 constraints in mind on scenario questions. 4 numbers worth memorizing, and more importantly, 4 decision boundaries. 10 knowledge sources is where Knowledge Assistant tops out. Past that, you need to consolidate sources or move to a supervisor. 30 agents and tools, combined, is the supervisor ceiling, which is also where you start thinking about splitting the routing problem in half. 128,000 tokens is the information extraction context window. Longer documents have to be chunked before ingestion, and 50 megabytes or 500 pages is the per-file wall for Knowledge Assistant, the kind of limit that silently breaks a pipeline if you don't size your sources up front. 5 things to take away. Agent Bricks is task first. You declare the job, the platform builds the evils and tunes the model. Knowledge Assistant uses an Instructed Retriever, engineered to beat plain RAG, not rapid. Multi-agent supervisor routes across up to 30 agents and tools, combined, and honors Unity Catalog permissions per user, automatically. Information extraction turns unstructured documents into schema-shaped JSON, deployable as SQL or a Lakeflow pipeline. And when the scenario needs custom judges, multi-hop logic, or non-English content, fall back to the Mosaic AI agent framework. Back to where we started, 40,000 PDFs, a cross-domain router, and a citation-grounded chatbot. Now you know exactly which brick handles each one, and when none of them do. Let's put it to the test with a quick 5-question quiz. Alright, time to put your knowledge to the test. Question 1. A museum team needs a visitor-facing chatbot that answers questions about its 200-page exhibit PDFs and curator notes, with every answer linking back to the source document. English content only. Which agent brick is the right fit? Is it A, multi-agent supervisor with a Genie Space subagent? B, Knowledge Assistant pointed at the Unity Catalog volume of PDFs and notes? C, information extraction with a schema for exhibit metadata? Or D, a custom PyFunc agent built on the Mosaic AI agent framework? Take a moment to think about it. The answer is B. The scenario verb is answer with citations over documents. That's the textbook Knowledge Assistant case. Supervisor handles cross-domain routing. Information extraction produces structured JSON rather than chat answers, and a custom PyFunc is only needed when no brick fits. Question 2. A team configures Knowledge Assistant with a Databricks vector search index that uses a custom embedding model they fine-tuned in-house. Ingestion fails. What's the most likely cause? A, the index must be a direct access index, not delta sync. B, vector search indexes are not supported by Knowledge Assistant, only Unity Catalog volumes work. C, Knowledge Assistant only accepts vector search indexes that use Databricks GTE large N as the embedding model. Or D, the team exceeded the 20 source limit on the assistant. Pause and think it through. The answer is C. Knowledge Assistant does accept Databricks vector search index sources, but only when the index uses Databricks GTE large N. Direct access indexes are actually rejected, only delta sync is allowed, which makes option A backwards, and the source cap is 10, not 20. Question 3. A logistics company has 60,000 incoming shipping manifests as PDFs arriving in a Unity Catalog volume every week. They want to extract sender, recipient, weight, declared value, and HS code into a Delta table for downstream analytics, with new files processed as they arrive. Which deployment fits best? A, information extraction deployed as a Lakeflow Spark declarative pipeline. B, Knowledge Assistant over the volume, with the analytics team querying it in chat. C, information extraction deployed as a one-shot SQL query, rerun nightly. Or D, a multi-agent supervisor coordinating a Genie Space and a Unity Catalog function. Take a moment. The answer is A. The verb is extract into a schema, and the qualifier matters, new files arriving incrementally. That's the Lakeflow pipeline path, which uses autoloader under the hood. The one-shot SQL deployment in option C works but wastes compute reprocessing old files and misses files between runs. Question 4. A scenario requires an assistant that can answer one user question by querying a curated sales delta table, searching unstructured Salesforce visit notes, and calling a Unity catalog function that looks up account tier. Different sales reps should only see data from their own region. What architecture should the team choose? A. Knowledge assistant with the sales table loaded as a Unity catalog table source. B. Information extraction across all three sources, materialized into one wide table. C. Multi-agent supervisor coordinating a Genie space, a knowledge assistant, and a Unity catalog function. Or D. A standalone large language model call with all three sources concatenated into the prompt. The answer is C. 3 signals point to supervisor: structured data through Genie, unstructured docs through a knowledge assistant subagent, and a typed tool through a Unity catalog function. And the per region access requirement is the giveaway. Supervisor honors Unity catalog permissions per end user, so each rep automatically sees only their region. Last question. Question 5. A team is designing a customer service agent that must call 8 external software as a service APIs in a multi-hop reasoning loop. Use a custom large language model as judge written in Python for quality scoring, and operate on Japanese language tickets. Which approach should they choose? A. Multi-agent supervisor with the software as a service AP is wrapped as MCP servers. B. Knowledge assistant with the software as a service API responses indexed in vector search. C. Information extraction to normalize the tickets, then a supervisor on top. Or D. Mosaic AI agent framework with a custom PyFunc agent. The answer is D. 3 signals together rule out every brick: multi-hop reasoning, supervisor roots but doesn't chain, custom code-based judge, the auto-eval can't express it, and Japanese content. Knowledge assistant is English only. When all 3 bricks are ruled out, the escape hatch is itself the answer, and that's the Mosaic AI agent framework with a custom PyFunc. And that's a wrap on agent bricks, knowledge assistant, multi-agent supervisor, and information extraction. If this helped, subscribe for the rest of the Databricks GenAI Engineer Cert series. It helps me keep making these lessons free, and I'll see you in the next one.